Hey there, and welcome to Home Reno Inspiration, where we inspire you to upgrade and fix your own home. Look, I get it. Sometimes you need professionals, but for most stuff, you can probably do it yourself. All you need is a little knowledge and inspiration, and you can do the job right too. As I said last time, I'm not an electrician. I don't do this every day. I'm a homeowner, just like you, trying to get my electrical work done. In part one, I talked about how I'm using the NEC, or the North American Electrical Code Manual, as my authoritative source. Today, in part two, I'm going to be talking about electrical wiring, and I'll present the different types of wire we'll encounter in our homes, and I'll also show you how to calculate circuit loads. Let's get started. I think the easiest way to start is with a list of definitions. The code starts this way, and I feel there is some wisdom to that. I'll list the definitions here and show real-world examples so this doesn't become too boring. If you know all this stuff, you're welcome to skip it, or stick around for a quick refresher. Here we go. Cable. This is a cable. A cable is composed of wires, or conductors, and an outer casing. In this example, the outer casing is made of nylon. Together, this can also be called a cable assembly. Romex cable NMD 90. Here's my same cable again, an example of the standard electrical cable used in homes in North America. When we look closer, we can read the details. Southwire is the name of the company that made the cable, and they're located in the state of Georgia, USA. NMD stands for non-metallic dry, which means this cable is rated for exposed work in dry locations or concealed work in dry or damp locations. 90 is a max temperature rating for the cable, 90 degrees Celsius, or equivalent to 194 degrees Fahrenheit. Romex is just the brand name. Simpull is a trademark that means the cable should be easier to pull without getting stuck. 300 volts is the max voltage rating. American wire gauge. AWG is the North American standard for categorizing wire by diameter, or gauge. Other countries may have either adopted the North American standard or use their own standard. 14/2. Here's my cable again. This is a 14 gauge cable with two conductors, black and white, and an unsheathed grounding wire. Technically, as we see here, there are 3 wires, but the industry doesn't count the grounding wire as a conductor. Black is the hot wire, or powered wire, or ungrounded wire, and white is called the neutral wire, or grounded wire. And this copper unsheathed wire in the center is known as the grounding wire. I'll get into this more in another video. Just so you know, if you're in the UK, the hot wire is red and the neutral wire is black. Maybe many other countries follow this standard too? Tell us in the comments below what standards exist in your country. Wire gauges. Here's a comparison between a cable with 14 gauge wires and 12 gauge wires. The 12 gauge wires are slightly thicker in diameter. Wires range from 40, a very thin wire, to 0, a very thick wire. There are even thicker wires too, like 00, 000, and more. In homes, we typically see 14, 12, and 10 gauge wires. Generally speaking, the thicker the diameter of the wire, the smaller the gauge number. 14 gauge is used in most of the circuits in our homes. Amps. Amps are a measure of electricity or current. The bigger the number, the more electricity and electrical devices can be supported on a circuit. Utility supply. This is the electricity service level and cable that provides supply to our homes. In my case, I receive a 200 amp service from my utility for a 3,000 square foot home. Smaller homes may be provisioned with less service, like 160 amps or 120 amps or even 100 amps, whatever. And bigger homes may have even more service. Patch panel. The utility supply comes into our homes and terminates at our patch panel. This panel is usually marked with the service level, 200 amps in my case, and a main breaker. Flip that main breaker at the top and we turn off all electricity supply to our home. The rest of the patch panel allows us homeowners to separate that supply into individual circuits to provide service to different parts of our home. So another way to say this is, a patch panel is just a collection of circuits. Circuit. I've mentioned circuit a few times already. What's a circuit? A circuit is just a pathway for electricity to flow. to supply power to the different devices in our homes, and it originates and ends here at the patch panel. A circuit, you get it? Circuit breaker. Each circuit is protected by a circuit breaker. If the amount of demand or load exceeds the available power for that circuit, the circuit breaker will trip and turn off the power to that circuit. That's a signal to you that something's wrong, and you'll need to figure out why so it doesn't happen again. It could be because of too much load, or there might be an exposed wire, or a crossed wire, or whatever. There's a problem. Figure it out and correct it. Then re-enable the circuit by turning it on, like this. Load. Load is the amount of demand or power that is required when operating a device. For example, I have some new pot lights here, and when I look at each light, it says 13 watts. That is the max load for this device. Circuit load. For circuit load, we just add up the load for each device in the circuit and we get a total. Available load. This is the absolute max load on a circuit. For a 15 amp circuit, that would be 15 amps. Max recommended circuit load. Let's look at the code. 8-104 section 1 says, the maximum ampacity will be either the ampere rating of the circuit breaker or the maximum ampacity of the cables, whichever is less. Also looking here at 8-104 section 6, it says, when a circuit breaker is marked for continuous operation at 80%, then the load should not exceed this 80% rating. And looking at this chart in Appendix B, Table 2 applies to us, and it says that for our 14 gauge cable at 90 degrees C, our maximum ampacity is 25 amps. Putting it all together, it turns out our 14 gauge cable can handle higher ampacity than our circuit breaker at 15 amps. So the code states whichever is less is our maximum recommended circuit load. So 15 amps. But keep this in mind. If we anticipate our load to be continuous, then we should not exceed 80% of the available load, or 12 amps. As a general rule of thumb, I think it's a good idea if we limit ourselves to just 80% of the circuit load for an additional level of safety. I don't know if you noticed, but sometimes our circuit loads are measured in amps, and sometimes our loads are measured in watts, so we need a way to convert. If you've completed high school, you might remember physics class where we learned the formula power, or P, in watts equals current, or I, in amps, times energy, or E, in volts. P equals I times E. All homes in North America support 120 volts for small load circuits like 15 amps, where 15 amps is the current. We plug these values into our equation and we get power equals 15 amps times 120 volts equals 1800 watts. Remember what I said earlier? We should think about provisioning just 80% of this capacity, or 1800 times 0.8 equals 1440 watts, which is equivalent to 12 amps on a 15 amp circuit. The main reason is safety, but if that's not good enough for you, how about another reason? Convenience. If your load is maxed out on a circuit, you may trip the circuit breaker, and if you do, you'll need to reduce the load and flip the circuit breaker back on. Sooner or later, something is going to fail, probably the circuit breaker, and then what happens? Yeah, keep this in mind. Now here's a question. Remember my pot lights I talked about earlier? How many of those can I put in a single 15 amp circuit? Let's find out. I said that the max watts for a 15 amp circuit is 1800, and that it's good practice to limit ourselves to just 80% of that, 1440 watts, right? I have 1440 watts to provision, and each pot light consumes 13 watts. So if I divide 1440 by 13, I get the maximum amount of pot lights, assuming of course that there's nothing else on the circuit like receptacles that could supply load to other devices. I get about 110 pot lights. Did you get that too? Perfect. Wow, 110 pot lights. Well, I'm not going anywhere near that maximum, but it's good to know. Okay, there we have it. We reviewed definitions so that we can all speak and understand the language of electricians now. We actually saw all of the components of a typical home electrical installation, and we learned about simple circuit loads and how to calculate them. Perfect. I hope this helped you get started. I look forward to your comments below.